How can we use group tables? What is cycle notation? What are subgroups? And what is the order of a group or an element? Hello everyone. First, a group table, also known as a Cayley table, is used to define a group by stating the result of the binary operation for each group element. This can only be used for groups with a small number of elements. To construct a group table, let G with binary operation dot be a small finite group and enumerate the set G starting from the identity element E up to Gn. Now, we make a table in which each row and column is indexed by a group element. In the ith position, we write the product G sub I dot G sub j. Every group table has the sudoku property, which says that each row and column contains every element exactly once. This is because we require that every equation in the group has a unique solution. Further, we have that if the group table is symmetric along its main diagonal, then the group is abelian, i.e. commutative. Next, cycle notation is a way of representing permutations. In this notation, we write a series of brackets to represent disjoint cycles. For example, if we had this permutation here, we would represent this as pi equals in brackets 1, then in brackets 3, 2. If the cycle is only one element, we don't have to include it, so the permutation can be written as pi equals in brackets 3, 2. Now, let's define a subgroup. Let G with binary operation dot be a group and let H be a subset of G. Then H with binary operation dot is a subgroup of G if H with binary operation dot is a group. It's important to note that the binary operation dot is the same operation on H as it is on G. We can check whether a subset is a subgroup by using the subgroup test. It says that if G with binary operation dot is a group and H is a non-empty subset of G, then H with the operation dot is a subgroup of G if and only if for all A and B in H we have that A dot the inverse of B is also in H. A handy result to know is that if H and K are subgroups of G with binary operation dot, then the intersection of H and K is also a subgroup of G. Now let's discuss the subgroup generated by a subset. First, let G be a group and X be a subset of G. Also, let this set here be the set of all subgroups of G that contain X. Then, the subgroup generated by X is represented with angle brackets and is the intersection of all of those subgroups. In fact, the subgroup generated by X is the smallest subgroup of G which contains X. This is an alternative definition for the subgroup generated by the subset X. Now, the order of a group G is the cardinality of G. Also, the order of an element G in G is equal to the cardinality of the cyclic group generated by G, where the cyclic group is another term for the subgroup generated by G.
As ever, thank you for watching.